Hey, good morning. I'm going to go ahead and go over part 1, so questions 1 through 5 for your exponential review. On the first part, the first two, we're asked to give the value of b and then tell whether or not it's growth or decay. So here, the initial amount, I know that's kind of misleading. We're not really asked to find that, but the initial amount is going to be that 3. And then the b value is what's inside, which is at 0.5. Because our b value is less than 1, it's going to be decay. On the second one, that initial amount's what's outside, so it's going to be negative 1/2. But our b value, what's inside, is 8, and since that 8 is greater than 1, it is growth. On the next part, questions 3 and 4, it says graph each exponential function, identify the domain, range, y-intercept, and asymptote of each function, and then express each range using an inequality. And we can actually do this without the calculator. The y-intercept is like our a value. It's the a. Remember, you have your y equals your a times b to the x. So the y-intercept is always what we start off with. So for question 3, it's negative, or for question 3, it's negative 3. Our asymptote, for our purposes, we're always looking at the x-axis, which is y equals 0. And because these graphs take on the shape that they take on, our domain will always be all real numbers. And so I'll kind of show you it real quick in the calculator. So here, it's never going to cross over the x-axis, so that's why it's our asymptote is y equals 0. And then for our domain, we're going to go ahead and stick with all real numbers. And the range, we can see it's in the bottom and it's never going to cross over. Our y-intercept is negative, so our range is going to be y is less than 0. Less than 0 because we want those negative values because our y-intercept is negative. Here on question 4, the y-intercept, once again, is what we start off with. It's at 2. The asymptote that we're looking at is the x-axis, which is y equals 0. The domain for our class, we're going to focus on all real numbers. And then the range, since my y-intercept is positive, it's going to be y is greater than 0 because it's positive. Where over here it was negative. So therefore it was less than 0. And then on number 5, we're talking about a verbal situation, so we want to make sure we're following our models here. It says a new car costs $15,000 to build in 2010. The company's financial analysis expect costs to rise by 6% per year for the next 10 years as they are planning to build the car. Okay, so it says write a model of cost to build the car where T is the number of years after 2010. So when we're writing, we need to know what is our A value, what are we starting off with. So here the initial cost is $15,000. We also need to know what is our interest. So that's 6%. So our R as a decimal would be 0.06. And then we are looking at an exponential growth because the costs are going to rise. So that's growth. So we're going to have that plus in our equation. Okay, so I'm going to start off with y equals that 15,000. And then because it's growth, it's going to be 1 plus that 0.06. And we are going to raise it to the t or x power for a time. And it says, what is the exponential growth factor? What is that b value? So we want to combine this together. So 1 plus 0.06 becomes 1.06. How much will it cost the company to build the car in 2017? So for this one, I'm going to go ahead and utilize my calculator. Okay. So I'm going to go ahead and type my 15,000, and then in parentheses, I'm going to put that 1.06, and we're going to raise it from 2010 to 2017. That is a difference of 7 years. I'm raising it to the 7th power, and then I press enter, and we get our new value. In 2017, it's going to cost us approximately $22,554, and if I round, 45 cents. All right.